So hello everyone, this is the channel about engines. I have a new series on my channel about repairing this engine and this gearbox. A subscriber came to me for repairs and here's the truck. So as you can see, it's an old Volvo from the 90s. My task is to repair the engine and the gearbox. Right now I'm starting by removing the gearbox. So I've already disconnected the air hoses here. Cool. There's a whole bundle going to the gearbox, to the gear shifter in Makoroko. Basically this whole bundle runs over there. I've disconnected the air hoses and now I'm removing the gearbox. Now we're taking the engine to the workbench and starting to disassemble it. So we've already removed the oil pan from the engine. If you look, the engine is standing without the oil pan like this. The oil pan itself is made of very thin sheet metal. For those who know, for example, the Xylo oil pan or the Jazzy 53 511, it's the same kind of thin metal and you can't really install it properly. It just bends right there. We removed the oil pan and oil pickups too. And here we laid out whatever we could find in a hurry, some pieces of wood, some plastic bottles, basically whatever we found we used. That's how the workshop looks right now. Now the engine model and its technical specifications will appear on the screen. And later we'll also repair this gearbox. So that's the scope of work we have. Let's get started. So I removed the fan and now I need to remove the gear selector, the gear shift lever first. To remove it, I need to free these air tubes, the bundle of tubes that goes to the gearbox. Here, I remove the air supply to the compressor, or rather, the air outlet from the compressor. We can see that the compressor has a separate air filter and this is how it's installed. So now I'm removing the coolant hose, taking off this air supply hose, pulling the bundle of these air hoses to that side, and removing the gear shift lever. To be honest, my first thoughts were, well, they offered MAN and Mercedes for repair, so just take a MAN or a Mercedes and do everything the usual way. No, I had to take a Volvo. The subscribers are waiting for variety on the channel. They write asking when there will be a Volvo, when you'll take some other engine. They're already tired of these MANs and Mercedes. Well, here you go, MAN, Mercedes. Well, I don't think it will have any effect on the channel. It's more or less all the same. I don't even know why I took it at all.
Subtitles made by Dimitrorzak.
So next, I need to remove the exhaust manifold and the coolant manifold. I look at all this and get upset. Basically, there are 4 bolts on the coolant manifold and the exhaust manifold. And the 4 bolts are arranged in such a way that you can only reach some of them with an open-end wrench. But I don't know, I've never seen an engine where everything was done like this. Next, remove the manifold by unscrewing 4 bolts, removing it from this cylinder, then 2, another 2, and finally 1 more. So, we can see that this bolt is accessible. You can reach this one with a wrench. But for these 2 bolts, it's not clear at all. There's a bolt under the manifold right around here. I have no idea how you could unscrew it. It's just a real mess. Plus, I can't remove the coolant manifold right now because I don't have access to all the bolts. I've never worked on a Volvo before, and I probably won't do it again. But I will, since I have another engine after this one. Another Volvo is coming, it's already booked, the advance payment's been made. But I'll finish this engine, then I'll do the next engine. That's it, I won't take any more Volvos. To be continued. The bolt is installed, but it's impossible to remove it from here. How is it installed? Apparently, you need to knock out this spacer, this washer, and then you can get it out. Very clear. I won't record the whole process. I'll turn the camera back on in about an hour. For now, I'll unscrew these 1, 2, 3, 4, 5, 6, 7, 8, 10 bolts, 9. That will take about an hour. Yeah, I used to think the D245 was unbeatable, that no other engine could compare to it. Turns out there are people who are even bigger hacks than that. So it's all good. The D245 actually turns out to be a pretty decent engine after all. Alright, so next grab the wrench and get to work. This is fucked up, damn it. Who the hell came up with this, damn it? It's just unbelievable. Honestly, to remove the manifolds in terms of time, effort, and inconvenience, I don't even know what to compare it to. Alright, stop whining. Thank you, subtitles. Yeah, Volvo fans can forgive me, but everything here is so poorly thought out, so primitive. I don't even know. It reminds me of the D245, it reminds me of the Kama's Z740. It's like that. There are all sorts of little tubes, inserts, gaskets, bolts and clamps everywhere. You definitely won't find this in MAN or Mercedes trucks. In MAN and Mercedes trucks, everything is completely different. Every little detail is well thought out there.
Here, they just threw everything together, however it came out.
For example, take the oil cooler. It's just, I don't even know what to call it. There's just some separate crappy ones standing there. Clamps everywhere, all kinds of eucalyptus. For example, with an open wrench, you can only use, after that it won't fit anymore, and so on. You can all these little things. you could list all this stuff endlessly. For example, to remove the compressor. So there's a mount that you can only unscrew with an open-end wrench. You can only use a box wrench the first time. After that, it won't fit anymore. Not to mention a socket or an impact gun and so on. So you can only use an open-end wrench. There are moments like this everywhere. These little things are all around. The nut won't unscrew any farther, so it hasn't come off the stud's threads yet, but now it's already stuck against the housing. Here's another example right away. To take it off the studs, you have to pull it this way. Here's one fitting, another fitting, and a hose between them. The total length of the hose is literally 10 centimeters. The free space between the fittings is 5 centimeters, so you have to pull the hose out here and pull the compressor out here. That's it, it's a hopeless situation. Either now I have to pry the hose with a crowbar, maybe even cut it. Well, who knows, this kind of reminds me of a UAZ engine. There too. To get to the lifters, you have to remove covers like this, or there I think one or two, I don't remember anymore. And the lifters are about the same as on the UAZ, just bigger.
To be continued.
So what can I say? I opened up the cylinder heads. For now, just my first visual impression, there is wear on the cylinder liners. The wear is significant. The liners definitely need to be replaced. Like I said, the wear is significant, but it's even. So, there aren't any deep scratches or anything like that. As for the engine block, I don't know yet. Of course, everything needs to be cleaned and checked. But I think there shouldn't be any problems with the block. At least at first glance, everything looks pretty good. So what's next? Next, I need to remove the pulley and take off the alternator. I don't know, maybe I'll try to rotate the engine now. It's awkward there. I couldn't rotate it when it was assembled to install. I'll try it now anyway. And I also need to remove the fuel injection pump. Line it up, check the marks, see how the ignition is set. I'm removing the pump, the alternator, and the power steering pump. I'm removing the front cover. There we'll line it up and check the timing marks. Well, next, we'll lay the engine on its side and start taking out the pistons, crankshaft, and so on. So, next I'm removing the fuel injection pump and have lined up the marks. That is, on the pump itself there's a plate with a mark, a stripe. And also on the coupling itself, on the drive itself, there's also a plate. You can see I've aligned them here. I opened the inspection window on the flywheel housing. And here we have somewhere around 24, 25, somewhere in that range, maybe 26. It's hard to see. So the customer said that he set the ignition a bit earlier. Ideally, this engine should have 19 degrees, but the customer has it set to about 25, so that's 6 degrees earlier. I don't know, we'll see during assembly, of course. We'll send the fuel injection pump for inspection. If this fixed mark here hasn't been knocked out of place, meaning it's set correctly, then we'll probably set it not to 25, but maybe a couple of degrees earlier than 19, like 20 or 21. I think somewhere in that range, but that's just my thoughts for now. After that, of course, we'll see how things go. That's it, I've lined up the marks. Now I'll remove the pump. I'll check if we should unscrew these bolts or those and see which is better. And also the pump mount. These 4 bolts here. And this looks like the oil drain, right? Probably the drain. There should be another oil supply. Yeah, here we probably have the oil supply under pressure. This is our oil drain. Everything in the flywheel housing is covered in oil, and it's not clear. It seems dry under the oil seal, but for some reason there's oil right under the flywheel. And here it looks like oil is coming from under the dust cover. In general, it's still unclear where exactly the oil is coming from. Right here it looks like it's running down along the bolts, or maybe it's being sprayed around. Well, of course we'll have a new oil seal. There might be some kind of gasket behind the dust cover. Maybe the oil is leaking from under it. We'll keep an eye on this and pay attention. So it looks like we still need to remove this hub. This here is probably the crankshaft itself. This is the shape of the end of it, like a triangle, right? So it turns out I need to use a puller now, hook onto the thread or something, and only then will this cover come off. So we see here we have a bunch of gears. 1, 2, 3, 4, 5, 6, 7. Here are 8, 9 and 10 too. 10 gears. This is our crankshaft. This is our camshaft. This is the intermediate gear. This is the fuel pump drive. This is another intermediate gear. This is the water pump drive. This is the power steering drive. This is the compressor drive. Here we have another intermediate gear and the oil pump drive. Alright, now I'm wiping everything down, setting the marks and checking the timing. Well, here it's probably like on the D245, like on the Mandy 0826. The intermediate gear won't line up with the marks right now. You have to turn it a lot of times here for the marks to line up. Well, let's take a look at it like this for now. Maybe we'll take it off and reposition it. So we're only interested in 3 gears: the crank gear, the cam gear, and the fuel pump gear, plus this intermediate one. Well, 4. The others don't need timing marks. Well, basically we can see that here's the crankshaft mark, here's the camshaft mark, and here's the fuel mark on the pump. So here we have a mismatch. This one is the fuel mark, and these two should be lined up here. Well, basically it's all clear. We don't even need to show it. Basically everything is clear as it is. Well, maybe you noticed how I'm struggling with these bolts, right? That is, on this engine, we don't use the metric system, but an inch-based system. That means all the bolt heads and caps are in inches. All the threads are also in inches. That's why I don't have any inch-sized tools, because I've never worked on inch-based engines before. This is actually my first engine like this. That's why I'm working with metric sockets. So this is how it should be. We can see the crankshaft is aligned, the camshaft is aligned, and the fuel timing is also aligned. So about the gear, here's what I want to say right away. Inside we have this type of bushing. We can see it began to crumble. So I don't know if this bushing can be replaced or if the whole gear needs to be replaced as a unit. So we already have this kind of problem. Well, the axle is in good condition. So here we have the camshaft thrust washer. As we can see, there's wear on this side. I don't know if we can try to grind it down or maybe replace it. Well, the wear is pretty significant. Alright, now we can take out the camshaft, but first I need to take out the lifters. I'm taking out the lifters, taking out the camshaft and removing this front cover. I'm not touching these gears, let them stay on it for now. Then I remove the cover, turn the block on its side and take out the pistons. So, the lifter is this kind of cup. Like I said, it's like the JSZ53 or ZMZ511, just a bit bigger in size. So, we can see that the lifter is chipped. We'll have to replace the lifters. Well, here we can see that, for example, the lifter on the first cylinder is badly crumbled. And usually, if the lifter is in this condition, the camshaft journal or lobe also suffers. It basically turns into an abrasive, and this abrasive wears it down. Okay, now let's take out the camshaft. Well, you can visually see that the cam lobes are worn down. The question is by how much? We'll take measurements and see how much they differ from the standard. So the cam lobes are still in pretty good condition. The size is standard. The bearing inside the connecting rod is in worse condition, and we can see that it's been crushed there, meaning it's loose. There might be some issues with the connecting rod. You can see that the rings are really worn out. I'll take one off now and we'll take some measurements. And also the pistons have scoring on them. So the piston assembly needs to be replaced. This is what it looks like. Alright, let's measure the ring now. Well, the gap is about 3 to 4 millimeters. It's a lot. 10 times more than normal. The main bearings are like that too. They're in satisfactory condition, but you can also see that it's not holding up well. That is, it was also crushed. And I also don't like this shine on the cap itself. Maybe. Alright, let's take it apart and see. So we can see that the liner was removed from the second cylinder. They smeared some sealant here, and basically the rubber ended up with these kinds of folds from the sealant. First, about the camshaft, we'll check the camshaft bushings. The customer said the oil pressure is good. I'll clean it, take a look. And for now, I don't know about the bushings yet. So, about the camshaft, as I said, some of the lobes are worn down. All of these here, these are the exhaust ones. So I took some measurements. It turns out this one is our worst lobe. And this one here, you could say, is in perfect condition. The difference in height is about 0.6. Well, I don't know. We'll still have to see about that. First, we'll check how much a new camshaft costs. Second, we'll see if these parts are available, whether there's a camshaft or not. Well, it will also all depend on the customer's wishes. If he says he wants a new camshaft, then we'll order and install it. If he says no, we can leave this one, since the truck isn't new. How much longer will it last? 3, 4, 5, 6 years? For that time, I think this camshaft is sufficient. Next, regarding the crankshaft, we probably won't do anything with it either. I took a preliminary look at. There's a bit of wear here, and there are some scratches here. Well, I think it's better to let it be. For example, you can see it clearly here. I think it's better to have a little bit of wear, let it be slightly undersized, rather than grinding it down to the repair size. Well, that's my opinion, and I've assembled it more than once already. So I've installed them at -600s and also at -56 and 700. In general, everything works fine. After grinding, first of all, it's very difficult to grind because you have to maintain all these dimensions. To make this fillet here, well, and ground crankshafts break more often. So I think we'll leave the crankshaft and camshaft as they are. About the piston assembly. The piston assembly definitely needs to be replaced. That's 100%. There is scoring like this on the pistons. There's scoring here, here, scratches and so on. That means pistons, rings, sleeves. All of that needs to be replaced. The piston assembly as a whole. Well, of course there are seals included in the kit, the piston pin is also included. So all of this needs to be replaced. Next, I can't comment on the engine block yet, it needs to be cleaned and measured first. We have some questions about the main bearing saddles, but we'll inspect them after cleaning. It's possible, not out of the question, that the block will need to go in for machining, but that's not certain yet. Well, also regarding the cylinder head mating surface on the block, also the seats for the liners. We'll check those too after washing and cleaning. That decision will be made later. Well, we'll disassemble the heads, check the condition of the seats, valves and guides. The heads may go for surface grinding. That's a bit of a design quirk here. This is the flange that sits on the sleeve. Well, we'll see. Most likely the heads will go to the surface grinder, so the turbocharger and the fuel equipment will also go for inspection. Based on the inspection results, a decision will be made about what to do with them. We'll also take the electrical equipment for inspection. The starter, alternator and pump will stay as they are. The customer recently installed a new one. Well, the compressor. Where's our compressor anyway? Yeah, the compressor is somewhere around here. We'll repair it, take it apart and check it. There's actually a peculiarity with our compressor. The cylinders are non-removable. You see that, right? So if there's wear on the cylinder, you'll have to buy an oversized piston and bore out the block or the housing itself. But we'll see about that later. We'll get to it. As for the clutch, I don't know yet either. We'll check the clutch. So now I'll make a list and get in touch with the customer. We'll decide what to do and what not to do. Well, then I'll keep cleaning everything. Some things we'll send out for machining. Some things I'll handle myself. I'll be disassembling the cylinder heads and so on. Some time has passed. I've already cleaned the engine block, and here's what I want to say. The engine block will definitely go in for machining, meaning the cylinder head mating surface absolutely needs to be resurfaced. We can see these kinds of pits, these holes. Also, machining the seats for the liners is a must. That's 100% necessary. The condition of the seating is questionable, as well as the main bearings. This all needs to be checked on the machine. All the machinists will take measurements and then it will be clear, but I think we'll have to machine the saddles as well. So I've already prepared the block, washed it, cleaned it with a wire brush in diesel fuel, in a jet washer, then cleaned it again with a wire brush and blew it out. That means the block is already fully prepared for machining. Probably in the next few days, tomorrow or the day after, it will be sent out. Well, maybe I'll unscrew the drain tap now, maybe I'll also unscrew this elbow so it doesn't get broken. Well, and basically that's probably it. So I also need to repair the fuel equipment. That the pump will go for inspection. So now I need to remove this bracket, to remove the hoses or the filters, and clean injectors. That the electrical equipment, including the alternator and starter, will be inspected. I also need to clean and prepare everything now. The turbocharger will also go for inspection. I need to remove the oil supply lines and the pipe. They bent it. Yeah, it's a pain. I need to remove the oil supply pipe and the oil drain pipe. I'll also clean it a bit, at least get rid of the worst dirt. I don't know, I'll take a look at this radiator and decide whether to remove it or not. Well, I also need to prepare the connecting rods for machining, which means removing them from the pistons, taking out the bearing shells, cleaning them and putting the caps back in place. So, what else do I want to say about this engine? When I was disassembling it, I mentioned that some bolts were installed in a strange way, and there were some bracket adapters and so on. Well, that's exactly how it is. As for the external mounts, there are bolts, adapters, rubber parts, and so on. All of that is really inconvenient. As for the internals, I can see that there is a very large safety margin here. So just by looking at the connecting rods, you can see the diameter, or rather the thickness of the wall under the piston pin bushing. The connecting rod itself, the width of the rod bearing shell, the cross section of the connecting rod, and so on. Everything is so robust, more robust than say on a Mercedes or MAN. Also, if we look at the piston, we can see the length of the skirt. That is, nowadays it's probably impossible to find pistons with such a skirt length. And the piston itself is so robust and massive. So in this regard, there's no question about that. The advantage of this engine is that everything is so robust, everything is made with a margin of safety. The diameter of the connecting rod journals, the diameter of the main journals, and so on. So it turns out we have our own advantages. This engine also has its own disadvantages. Continuation. So I'm starting the assembly. All the parts have already been purchased and the engine has already undergone machining. As for the machining work, Everything is standard for us. This is the cylinder head mating surface. These are the seats for the liners, and these are the saddles for the main bearing shells. So the block came back from machining. I've already blown it out, got rid of the biggest chips myself first. My task now is to clean all the channels, remove the oil jets, take off some plugs, basically blow everything out, clean it, and prepare the block for assembly. So today is Saturday, and the liner shims will only arrive to me on Monday. Let me explain briefly why this is the case. Well, we're waiting for the machining to be done, for the machinists to finish their work. So, as we can see here, for example, we have 0.3 mm for the 6th cylinder. We need a 0.3 mm liner shim, and here we have 0.8 mm. The adjustment ring for the 5th cylinder. The 4th and 3rd cylinders are installed without adjustment rings, just the liner itself. The 2nd cylinder needs a 0.3 mm ring, and the 1st cylinder needs a 0.5 mm liner shim. And also from the block itself, well, from the block's deck surface we remove 0.3 mm. If we look, we can even see some small pits like this. They're really minor, but overall these are just little things. The mating surface is basically perfect. So here's another issue with this block. Since the engine is already old, from the 90s, I think it's from 92 if I'm not mistaken, this edge here is supposed to be sharp, but it's already pretty rounded. You can see there's corrosion here, and there's nothing you can do about it anymore. It's basically beyond repair. So what will I do with this? I'll do something. We've installed a new seal, and I'll apply sealant. I'll put on a generous amount of sealant, and then I'll clamp the liners so they stay pressed for a day. This way, the sealant dries in the correct position of the sleeve. Well, I don't really have any other answer. I don't have any other options for what I can do with this. Well, I think we shouldn't have any problems. I think everything will be fine. Well, that means I have Saturday and Sunday for some more prep work. Like I said, to work on the block and do some more prep. I still have some work to do with the cylinder head. By the way, we took rusty cylinder heads like these for pressure testing. I replaced one injector sleeve here, plus I needed to check the 2nd cylinder. Yes, the customer had complaints about it, that antifreeze was leaking. In general, I don't have the ability to pressure test cylinder heads like these. We sent them to an external company for pressure testing, and we brought them back. I got them from Pescostroy. They were in perfect condition, and we brought them back. This is what they look like. So it turns out they do the pressure testing in regular water, and obviously they all started to rust. I don't know. Now I have to do something about it again. Well, that's okay. These are just little things, details. But again, the organization that specifically deals with repairing cylinder heads, blocks, cylinders, does pressure testing and replaces all sorts of seats guides and so on. And this kind of attitude too. I don't understand. Couldn't they have used antifreeze or some kind of lubricating cooling fluid? I don't know. But that's a fact. The fact is that now I need to do something with the cylinder heads, and they're in this condition. So, as for the cylinder head, I still have some work to do. Here, the exhaust valve has already been lapped, the guides have been replaced, and the exhaust valve has been lapped. And I still need to lap the intake valve, since I didn't have any intake valves available yet. And the cylinder heads went for pressure testing without a lapped valve. So I still need to lap 6 valves on this head. As for the rest, everything is basically ready. Now as I go along, I'll be explaining and talking about things. For example, I opened up the oil pump and checked its condition. I also took apart this intermediate gear. We have a new shaft. There's a new bushing on the gear. We've also replaced the bushing on this gear, but the bushing is used. We couldn't find a new one. Okay, we bought a used gear like this one, but I didn't really like the gear itself. I mean, the other gear is better. So I took the bushing from this gear and installed it on the original gear. And about this intermediate gear that drives the oil pump, there's this kind of wear on the shaft itself. I don't know how well you can see it on camera, but here it's really deep. It's about 3 or 4/10 of a millimeter. And this shaft is from the company Lassa, so it was replaced at some point. I'm not sure, it was replaced during a repair. A new shaft has been installed, and a new bushing has also been installed on the intermediate gear of the oil pump drive. I also opened up, for example, the fuel pump drive. Here I replaced the bearings, replaced the seals, I installed everything there. I installed new rubber seals, I used sealant. So a lot of work has already been done. Now, a little later, I'll show the footage I have of the prep work. Some things I did without the camera. Basically everything is already cleaned. Everything is ready after sandblasting. The fuel system was also repaired, the pump and injectors. We also had the turbocharger repaired. Electrical equipment. Also, for example, the casing was welded. When I took it apart, or rather when I cleaned it, I found cracks like this in these places. So we took the casing in for about 8 centimeters of argon welding. Now my task is also to even this out a bit, to smooth it out. Especially in this spot, as you can see. The weld went right onto the mating surface. In general, there is also some work to be done with the casing as well. For example, new studs need to be installed. New studs have been purchased. One of them was broken here and some were stretched, so I already have the gearbox from this truck ready. I don't know which series will come out first, either about the gearbox or the engine. Well, the gearbox is already completely ready and painted. It can be installed. So now you'll see footage of the preparatory work that I filmed for this engine. Well, and then, as I said, we work on the block. Alright, let's go. Alright, so I'm taking apart the heads, and here's the second head, the exhaust valve. There's this kind of play. Well, the customer did say there were problems with the second cylinder, but the customer said that coolant was leaking outside. It's seeping through the head. But we can see that it's not just coolant leaking here, the valve guide is also worn out like this. Interestingly, the customer didn't complain about the power. The power was fine. It's really interesting how, with that much play in the exhaust valve, everything still worked. Yes. We'll need to replace the valves since there's this much play on the first cylinder as an example. But the valve itself is already worn out, meaning the valve stem itself is eaten away. So accordingly, the valves need to be replaced, and the valve guides also need to be replaced. And there's another interesting point. There are no valve stem seals on the guides. I've seen this on some MAN engines. They also don't have valve stem seals from the factory. And as we can see, this engine also doesn't have any valve stem seals, just a bare guide. So I'll see if I can find any valve stem seals that fit by size, and of course it's better to install them if possible. Also, I checked and the springs are the same. There can be differences, for example, the intake and exhaust springs can be different in height. For example, the coils are installed in a specific direction. You can't just flip them any way you want. Sometimes they differ in color. Here we can see that the springs are the same. Next I'll be assembling the compressor. As for the compressor, basically things aren't that bad. There's practically no wear. The crankshaft is in excellent condition. The connecting rods are in excellent condition. Now I'll be disassembling the head, checking and overhauling it. So what kind of repair will we do on the compressor? I'll install new piston rings here, 2 sets and a gasket repair kit. Here we have gaskets and valves. Everything else will remain as it is. The piston rod, crankshaft, connecting rods, pistons. The cylinders too. Here they're non-removable. Well, most likely there are oversized pistons, so you can bore it out to a larger size and install oversized pistons. But in our case we don't need that right now. So that's the scope of work for the compressor. Let's get started. Next I'm assembling the head. I've washed, cleaned and degreased everything. Placed the valves. The old ones just come out like this. They're threaded and I installed new ones. And they're fastened with bolts, meaning the head is tightened together. 2 bolts are screwed into these valves and as a result they're pressed in there. I replaced these valves. Now I'm installing new gaskets, new intake valves and assembling everything. To be continued. To be continued. So The engine block is still at the machine shop, but it should be with me in a few days. So as you can see, my transmission is still disassembled, meaning there are some issues with the parts for the transmission. I'm waiting for them. The engine block is also taking longer than expected. It's been at the machine shop for a long time. In general, the repair of this truck is also taking longer than expected. Well, I don't know. It is what it is. Right now, I want to unpack the piston set. One of the sleeves is also at the machine shop with the block for measurements. I'll start with the block and the mating surface, the cylinder head. We removed 3/10. And what do I want to do now? I want to machine each piston, trim it by the same 3/10, somewhere around 30 to 35 hundredths, maybe up to 4/10 within those limits. So that my pistons are already ready, because every time I take measurements, I keep thinking that maybe it'll be fine and I won't need to trim the pistons. And every time the measurements show me that it's exactly the amount that was taken off the block cylinder head mating surface, that's exactly the height I need to remove to trim the pistons. So now we're unpacking, taking measurements of the piston rings, checking ring end gaps in the cylinder liners, and each piston as well. I take them one by one to the lathe and trim each one, taking measurements. In general, I won't be filming this whole process, basically. I've shown this before on my channel. I'm preparing the pistons and will install them onto connecting rods next. This is our heaviest piston. 4869, 4869. 69. And it turns out this one, I think, is our lightest. 4000, 4056. Well, the difference is about 13 or 14 grams. That is with the weight of the piston pin rings and clips, with a total weight of almost 5 kilograms. According to the literature, the allowable difference in piston weight is up to 100 grams. We have 13 grams, so everything is just perfect. So practically under every video people ask, well, of course there are different viewers, but still under every video there's a question. How is this dimension restored if it's being machined? I mean, it gets bigger. Let me explain in a few words. You can see that the caps are also ground. So they remove material from the cap from this spot and set it deeper, so it ends up closer over there. And this hole becomes oval. That is, in this spot the size doesn't change. If we look at the cap, there's only contact with the cutter in this spot. That means here we still have the old surface that hasn't been removed by the cutter. On the rest of the cap surface we can see that it's been cut by the cutter, so the hole becomes oval shaped. They align it according to this measurement. This is taken as 0, meaning the cutter just touches the block here. And as a result, mainly the cutter removes material from the cap itself. As a result, they achieve the desired measurement. Right now we have the perfect size here according to the manual as it should be. And also the perfect geometry. That means there are no taper, skew, ovality or anything like that. So, this is how they restore these seats for the main bearings. So the block is ready and I'll start the assembly. As I mentioned, I don't have the adjustment rings yet, so I'll assemble what I can for now. Now I want to install the camshaft and put in this thrust washer. Maybe I'll put on the front cover. I'll install the crankshaft first, then put on the front cover. And then I'll probably work on the cylinder heads. The camshaft will be new. As I showed before, there were some issues with the old camshaft. Well, in general, we checked the price of the camshaft. So the customer agreed to buy a new camshaft. The camshaft that was installed on this engine was also not the original one. It was from the OE brand, if I'm not mistaken, or BF, so it had also been replaced at some point. This is a camshaft from the new OE brand. There will also be a new camshaft gear. There are some concerns about the old gear. The teeth have started to chip. Next, I will be installing the crankshaft, which I have already prepared. I clamped it in the machine and polished it. I unscrewed these plugs here, these kinds of plugs. This is also a reference to engines of Soviet production, like the ZIL-130, ZMZ-511 and so on. But there, in the journal, we have such a large cavity so that all the dirt, any shavings and so on, accumulate there from the centrifugal force. Here we just have drilling, meaning the channel is drilled from the connecting rod journal to the main journal, and as a result there is a plug in this spot. But when I unscrewed these plugs, there was also a large amount of this black dirt there, dry and compacted. Well, those who have open crankshafts know what I'm talking about. But so, I had to clean it out with a drill, because the dirt was so compacted that I couldn't get it out with an awl or anything else. So I cleaned all the channels with a drill bit, then used a brush on a drill to clean all the channels as well. Then I blew them out and washed them with a special solvent. The crankshaft is fully prepared. All the channels have been checked, all the channels have been cleaned, and this is roughly how they look. So I polished the crankshaft at the tail end where the oil seal is installed, and there's this kind of wear from the seal. Well, there's nothing I can do about that anymore. I'll see, maybe I'll try to shift the seal a millimeter to one side or the other, just however it works out. So as I mentioned during disassembly, the crankshaft has some minor wear, each did. There are some small scratches here and there, but I took measurements, and it's about 0.04 millimeters on 0.03 to 0.04 millimeters. Well, like I said, in my opinion, it's better to leave it with minor wear than to grind it down to the next undersize. Alright, so now I'm installing the plugs with thread locker, and then I'm unpacking the bearings, unpacking the new thrust washers, and installing the crankshaft into the block. Okay, I've tightened it. Continuation. On the side, and now I'm going to tighten it with a torque wrench. According to the manual, the bolt should be tightened 340 Newton meters, plus or minus 25. So that means from 315 to 365. I'm going to tighten it to the maximum, set it to 365, and let's tighten it without an additional 90-degree turn. So I tighten it to 365 and then continue. Alright, my crankshaft is tightened. I make these marks just for myself, so I know that all these bolts are tightened. Next, I'll probably install the front and rear covers. Well, and rest. I still need to install the sleeves, pistons, and then we'll close it up. I'll already be able to put on the oil pan, or at least the day after tomorrow. So I finally got the rings. The rings come in size, and somewhere I put in paint. Somewhere I put one ring each, and on the 5th cylinder we have 2 rings, 0.5 and 0.3, which makes 0.8. Here we have it without rings. Well, I showed all of this. Subtitles created by Dimatorzok, to be continued. I installed the sleeves without him, as well as the rings. That's all. Subtitles created by Dimatorzok. That's it. Ideally, editor and proofreader Igorova. So, according to the literature, we look at the profile of the upper part of the sleeve. The amount of protrusion relative to the joint plane on the cylinder block is from 0.47 to 0.52 mm. So here we have this block indicated. This is the sleeve, this is the flange, and the size A is 0.50. Well, roughly speaking, half a millimeter. So, why is it made this way? This flange fits into the head. Here is the groove that I showed. So, the gasket is initially flat, but when you tighten the head, this flange presses the gasket into the groove on the head. It forms a lock using the gasket's own body, deforming as it's pressed from both sides. Honestly, it's an interesting solution. I can't recall seeing anything like it elsewhere. Now, I'll show the cylinder liner protrusion on camera. Then we'll take out the liners, install new seals, and put the liners back into the block. By the way, as I mentioned, I'll be installing the upper seal with sealant, so now I need to figure out what I'll use to press it in. All the liners, that is at least each liner in 2 planes at 2 points. I'll clamp it, install it, and leave it until tomorrow so the sealant sets and dries. So I'll first show it on the unclamped liners, and then we'll clamp a couple of liners and see how much the value changes, if it changes at all. So as we can see, the block is at 0. Then we move over to the liner, 0.50 millimeters. The block is at 0. The liner is at 0.50. Well, it shows here depending. There's also this little ridge, so it depends where you measure, but on average it shows 0.52 to 0.54 millimeters. But since the liner isn't clamped yet, we'll clamp it some more. Next, the block is at 0. The liner is at 0.54. Next one, the block is at 0. Liner 51. Next block 0. Liner 50, 0. To be continued 51, 52. Wow. 5th cylinder, block 0, liner 53. 6th cylinder, block 0, cylinder liner 53. Now we'll snug down a couple of liners and see how our values change. Let's take a look. The block is 0, the cylinder liner is 53 hundredths. The block is 0, the cylinder liner is 53 hundredths. So I installed the cylinder liners yesterday. That's what them now, and they've been sitting here for almost a day now. I'm not touching them yet, so the sealant can dry and set properly. Itpuka ishize natsu off. In the meantime, I decided to work on the cylinder heads. As I mentioned before about the cylinder heads, the exhaust valves have already been lapped and marked according to their positions, from which valve came from which head. You can see the imprint from the seat here. And now I'm going to unpack them. I've unpacked the intake valves. Everything is prepared here as well. The valve seat has been recut. Now I'm lapping the intake valves and assembling the cylinder heads. This will probably take me the whole day today. The engine block will stay as it is until tomorrow, and tomorrow morning I'll start installing the pistons and immediately close up the cylinder heads. Well, basically everything is ready there. The cover and the oil pan. I think I'll close up the oil pan tomorrow. So it's the next day. Yesterday I spent the whole day lapping these 6 valves. Well, not the whole day, more like the second half of the day. I didn't film the process, did everything off camera. So the valves are already lapped, and I've prepared the collets, springs, retainers and washers. So, like I said, there are no valve stem seals on these heads, and I couldn't really find anything that would fit by size either. So we'll assemble it as it should be, without valve stem seals. Well, the guides are just perfect now. There's no play at all. So I'm assembling the heads, and finally we'll be installing the pistons. I've installed the pistons. Now I'm going to tighten the connecting rod bolts. The bolts are tightened according to the following procedure. So obviously the first phase is 4, the second phase is 7.5, 75 Newton meters, and the third phase is to turn it 90 degrees. I'm also immediately measuring the piston protrusion above the cylinder block. As we can see, the block is at 0 and the piston is at 2/10, 20 hundredths, the block is at 0. Well, it's not 0 here, it's showing about +1. Here it's showing around 18 or 19, so roughly speaking about 15 to 20 hundredths. Let's look further. The block is at 0. The protrusion is the same 18 hundredths. Well, I've already measured all the pistons. All of them have a protrusion from 15 to 20 hundredths according to the literature. According to the literature, the maximum protrusion relative to the joint plane here is 0.55. So it's interesting that only the upper limit is specified, the lower limit isn't mentioned. But as far as I know, usually the value ranges from 0 up to a certain size. So here I think it's also from 0 to 0.55 millimeters. Let me remind you, our average value is 0.2 millimeters, which is within the normal range. So next I'll be installing the cylinder heads, and I've prepared the gaskets. The gasket itself is just a plate like this. A plate with holes. Yes, there are no seals anywhere, no ridges or anything like that. So it's just a plate. Also, the set comes with a box like this, and here we have these little bushings of different diameters. So this is a bushing for the push-rod passage, and this is a bushing for the coolant channel, and the smallest one is for the oil feed passage. And there's also this pack with a huge number of rubber seals. That means I've installed the gaskets. This is how it looks. So each cylinder head gets 5 of these bushings and rings, which means my cylinder heads are also prepared. Here, as I mentioned, I replaced one copper injector sleeve. So here it is on the first cylinder. I don't know how well you can see it on camera, but the new sleeve is installed. So after that, I had the cylinder heads pressure tested. During the pressure test, they found one defect. One of the plugs was leaking. They opened it up on the spot, replaced the seals, screwed it back in, and did the pressure test again. So there are no issues with the cylinder heads either, or with the head bolts that fasten them to the cylinder block. Here we still have the old bolts, 16 of them. So that's 8 bolts per cylinder head, 16 in total. We still have the old ones. These are the original bolts that were installed at the factory. So I rejected these 16 bolts. You can see they have these kinds of pits and grooves, some bigger, some smaller. So these 16 will be new, and the other 16 are bolts that were replaced at some point. So They are also from the company Diesel Technic, but they are still in good working condition. So we have 16 old Diesel Technic bolts, 16 new Diesel Technic bolts, and 16 original bolts that came from the factory. Alright, let's unpack the bolts and install the cylinder heads. Let's go. So I installed the cylinder heads and tightened them with the gun, just a little, not even up to 5 kilograms. Basically just set them in place and snug them up. I got the wrenches ready. First I tightened with the small wrench to 5 kilograms, then with the big one to 15 kilograms, and then the third phase I think is 19 kilograms, that's 190 Newton meters, and then the fourth phase. We do an additional 60-degree turn. It's interesting. Everywhere else it's 90 degrees, like the same. Connecting rod caps are 90 degrees, but specifically the torque for tightening the cylinder head bolts is 60 degrees. We'll stick to what's written in the manual, so now I'll tighten to 190 and then an additional 60-degree turn. Yeah, it's very interesting. The bolts are tightened because the gasket deforms there, meaning it gets pressed out by the cylinder liner's lip and pushes the head into the head's recess. So I tighten it, then go back to the first bolt again, and it turns out it can still be tightened. The same 140 Newton meters, it still tightens more. So I tighten the 6th head bolt with a force of 140. Now I'm setting it to 190, tightening it, and then turning it another 60 degrees. So this here is 200, here we have 190. Vi måste. So I made marks at about 60 degrees, and now we're tightening so that the marks line up. So I was installing the cover just now and messed up. People often ask, don't you ever make mistakes? Show us your mistakes. Alright, I'll show you. Oil seal. So where? The oil seal, basically, tore. You can see right on the working surface, there's a crack like this. This oil seal came with the gasket set. A full gasket set was bought for this engine. Erling brand. The set included the oil seal. But for some reason, there was no drift. Usually oil seals come with a drift, especially with this setup. It's really inconvenient. There's no chamfer, nothing, no lead-in. Here it's really hard to install without a seal driver. Now I'll call the supply guy and let him know that I messed up and broke the oil seal. Let him look for a new oil seal. Now the question is, when will this oil seal arrive? Well, if for example I get it tomorrow, that would be good, but if I have to wait several days for it, that will be a complete pain in the ass. It had to happen. Alright, now we'll probably look for an oil seal that comes with a driver, because without a driver, it's a real pain. So that means we'll only have the oil seal tomorrow. For now, we don't have the oil seal. So for now, what did I decide to do? I installed the cover with a couple of bolts. I installed the flywheel with 3 bolts and tightened it. So now I want to set the timing marks and install the fuel injection pump. Here, I set the mark on the crankshaft and set the mark on the gear. Now I need to install the intermediate gear. The pump was tested. Actually, the fuel system was repaired. The injectors were repaired. The pump was tested and everything is fine with it. The customer said the pump was supposedly repaired recently. So I installed this bracket, tightened the bolts, wiped it down a bit and degreased it. It was covered in oil and diesel. That's it. Now I'm working on installing the pump. Alright, so I'm installing the pump. I lined up the mark on the pump. Here we have a fixed mark. And on the hub itself there's also a line that I aligned. I also set the engine to the right position. Well, since I haven't put the oil pan on yet, I'm checking by the camshaft. That is, we can see both cam lobes are facing toward me in this direction. It turns out that right now the first cylinder is at top dead center. Okay, compression. Well, and after that I set it to 21 degrees here. That's it. Now I'm installing the pump and tightening these 4 bolts. Then I install the oil drain tube. Actually, yes, this is the oil drain. Then the oil supply. I also install the oil drain fitting from the turbo. Well, I'll close this up right away too. I think there was a valve here. I'll close all these holes. Take a look. And then I'll start mounting the pump to the damper plates. So as we remember from Disassembly, it was set here at 25 degrees of ignition timing. 25, 26. Now I'm setting it to 21. So I need to shift it a little here. I'll loosen this bolt and shift the whole mechanism relative to the shaft. It might just be a millimeter or so. Well, as for the timing mechanism, I installed a new gear on the camshaft. I put in new bolts and used thread locker on them. I also installed this plate that holds them in place. Everything here is tightened. I also installed this intermediate gear. The bolts are secured with thread locker. And here is the pump drive gear. As I mentioned, I disassembled everything here. I replaced the bearings and seals. Everything here is also secured with thread locker. Now about the timing marks. Crankshaft 1 dot. Intermediate gear 2 dots. Next, the fuel pump 1 dot. 2 dots. And camshaft 1 dot. 2 dots. All my timing marks are aligned. To be continued. So I installed the engine in its working position, installed the injectors as I showed, and installed the rocker arms, or rather, first I installed the new lifter, then the push rods, and then the rocker arms. So I've already adjusted the valves. The valves are adjusted exactly the same way as on the MAN 2866. For example, we adjust them by bringing the first cylinder to top dead center like this on the compression stroke, turning it clockwise. Turn the engine until the intake valve opens. After the intake valve operates, we catch top dead center on the cylinder and start adjusting the valves. Or you can turn the engine clockwise until valve overlap occurs on the sixth cylinder. That is, one valve finishes closing and the other valve starts opening. At this moment, the first cylinder is at top dead center on the compression stroke, and we adjust the first, second, and third valves, skip the fourth and fifth, adjust the sixth and seventh, skip the eighth and ninth, and adjust the 10th. Then we rotate the engine a full turn, 360 degrees, and adjust. The remaining valves are the fourth, fifth, 8th, 9th, 11th, and 12th. But there's another point: the clearance is different from the MAN 2866. For example, the intake valve here has a clearance of 0.4 millimeters, basically the same as there, but the exhaust valve here has a clearance of 0.7 millimeters. Well, apparently, because the pushrod itself is much longer and the valve itself is longer, the thermal clearance ends up being larger. And according to the literature, the clearance is specified for a cold engine. Intake 0.4, exhaust, that's it. So does that mean ours aren't adjusted? Now I'm going to put the valve covers on. So I'll be closing these covers that cover the pushrod windows, and then I'll install the intake manifold. Put on the compressor. And I also have the filter housing ready here, so I'll install that as well. By the way, the oil cooler is still lying over there. I haven't even washed it yet. I haven't started working on it at all. I can also install the clutch pressure plate. The new basket is lying over there, along with the new disc. I also need to install the exhaust manifold. See, it's on the shelf over there, already painted. The starter is installed, so I'll be putting everything together now. I think in another day or two, the engine will be ready. So the engine is assembled and ready for installation, meaning there won't be a startup here. Well, first of all, the engine already needs to be installed. The repair deadlines have already been delayed, so probably tomorrow the engine will be installed in the car. And secondly, I still don't have the oil yet, so there are reasons for that too. The oil is still somewhere on the way, so I have to wait for the oil to arrive. I don't see any point in starting it up here and then installing it. The engine will be installed tomorrow and the person will be working on connecting it. There's still work to do here. It's not a one-day job to install and connect it and so on. So I hope to film it starting in the truck. I think you'll see this engine start at the end of this video. Now, about the cost of the repair. Now the on-screen text will appear here showing the amount that was spent on repairing this car. Well, that's the total amount. Engine repair, transmission repair, meaning all the parts for the engine and the transmission. These are all the works done on the engine and the transmission. As for repairing Volvo, like I said, I won't do it anymore. I will take Volvo in for repairs. Well, after this car I should have another car coming in, also a Volvo, for repairs. I think it has a different engine, if I'm not mistaken. I'll fix that engine and after that, that's probably it. So people write to me saying, how can you not take it? You'll still take it. It's money. I want to answer those commenters that, yes, I have a lot of options. A lot of people come to me. I probably don't even cover 5%. Maybe only 3% of the demand. Because I just physically can't take everyone's car for repairs. So yes, I choose which engine to take for repair, which engine not to take for repair, and so on. There are plenty of offers for repairing Mercedes, plenty of offers for repairing MAN, and so on. So, with Volvo, this is a rare case on our channel. Now, about the assembly, well, obviously, everything is washed, cleaned, and prepared now. That's why the assembly went much better than the disassembly of this engine. But still, for example, there are some things I just can't understand, how they could have been done that way. For instance, there are 4 bolts on the manifold. Well, okay, let's say, fine, let have 4 bolts. That's kind of more reliable, I agree. There are 4 bolts on the exhaust manifold. But let's say if we look at that same oil cooler, the most confusing part of this engine to me is the oil cooler. Its design, its mounting, well, basically everything about it. So if we look at the oil cooler, this is the main oil gallery. So if something happens here, that's it. You could say the engine is done for. The engine will be done for in just a matter of minutes. So we see there's this kind of canister. It weighs about, I don't know, maybe 5, 6 or 7 kilograms by itself. Plus, when it's running, it's also filled with coolant and oil. So it turns out, I don't know, it's more than 10 kilograms. And it's all held by a little stud like this, an 8mm stud, a nut, and a clamp like this. This turns out to be the only mounting point for this whole unit, this entire heat exchanger. Well, and also, this same mounting is responsible for sealing these channels. In my opinion, that's complete nonsense. The seating here is already damaged. In any case, this oil cooler moves like this when the engine is running. This whole section isn't supported at all. It's pretty heavy. There's still vibration coming from the engine. The seating here is already damaged. There's wear on the aluminum. The sealing happens with 2 rings, rubber rings. The seat for these rings is damaged. But I did install new rings and use sealant on everything. I applied sealant. I'll tighten it here. I put in washers where I could to pull the clamp closer. But in any case, I don't really understand the design of this heat exchanger. It would have been better with 2 bolts on the exhaust manifold, but they did everything else properly. So, I think I didn't show it on video, but I also opened up and took apart this oil filter housing. Here we have a pressure relief valve and a bypass valve. Well, in case, for example, the filters get clogged, so that the oil can still go into the system bypassing the filters. There's a bypass valve. I also took it all apart, cleaned it, and checked it. Also under the filters, right here on the block. Well, I don't know, maybe you can see it. It was visible earlier in the video. There's also another pressure relief valve. I also opened it up and checked it. So, I installed everything I took off here in the workshop. I installed the shift lever. The engine will be installed on the truck without the transmission. The transmission will be installed separately later. Well, it's better this way, it's more convenient. So all these air tubes, I cleaned them and blew them out. I secured them here to keep them from dangling and getting in the way. I also installed this bracket here which holds the filter. Here we have the air filter. Well, I installed it so I could tighten these bolts. Here we have a loop for lifting the engine. We'll need these loops before installation. Well, in any case, we'll have to remove it later once it's in place because it's attached with these studs. which I use to mount the transmission. Alright, that means I'll be wrapping up this video. That's how our Volvo engine repair turned out. Thank you all for watching. Good luck to everyone. Goodbye everyone. Bye.
Subtitled by Nito.